Alright, so adding and subtracting rational expressions is actually more difficult than multiplying and dividing. That's why we put it second. So let's try a few examples. In order to subtract these fractions, we need a common denominator. So the LCD of 6x and 15x is 30x. Personally, if you have trouble figuring out what LCDs are, in this case, this is a method I've seen once. Someone did this. I think I saw it on a website called Purple Math. Alright, they made a little table. These are the two denominators in this problem. And they listed all the factors of the denominators. So this was 2, 3, and x. And this is 3, x, and 5. And to find the common denominator, you just ran down every common item pair. So 2 is needed to have a common denominator. The 3 is covered by both of them. The x is covered by both of them, and the 5. Put that together, and we get 30x. So that's our LCD. If you have trouble doing that, you can just multiply them by each other's denominator. It just means there'll be more to simplify at the end. So we're going to multiply the numerator and denominator here by 5 to get 30x, and the numerator and denominator here by 2. So our new fraction will be 5y over 30x minus 2y plus 4x over 30x. Now that we have a common denominator, we can rewrite this expression in the numerator over this common denominator. So this is now over 30x 5y minus this expression minus this expression. This is the part where most people mess these things up. 2y plus 2x. Because we're actually subtracting this entire numerator from this entire numerator, we actually should include parentheses. Alright, this is where most people mess up. So if we do this subtraction, 5 minus 2 would be 3y, and nothing minus 2x. Oh, I'm sorry, that's supposed to be a 4. Rewrite that so you can read it. 4. So, whoops. Alright, so 0 x's minus 4 x's is minus 4 x's. All of this is over 30x. Looking at our denominator at this point, we see the only excluded value here would be 0, since that would make this fraction undefined. X is not equal to 0. If you look at both of these, you'll see it was equal to 0 to begin with as well. So this would be our final answer. Alright, let's take a look at another example. In this case, we actually have a common denominator. A lot of the problems that you'll see will have common denominators. The issue that people have with them is, again, putting the parentheses in when they do them. So this should really be 5x minus 4, that entire numerator, minus x plus 6 over their common denominator. Redo that. X plus 6. All of this is over 9x to the third plus 27x squared. Alright, so we'll combine these terms. 5x minus x is 4x, and minus 4 minus 6 is minus 10. All of that over 9x to the third plus 27x squared. Can we simplify this? The GCF of the numerator is 2, and the GCF of the denominator is 3x squared. While simplifying this isn't helpful, this is our final answer. It might be helpful to simplify the denominator to find the excluded values, so I'm actually going to do that anyway. So that's 2, 2x minus 5 over 3x squared. This is 3x plus 9. Oh, wait. I guess I got a GCF of 9. Let's do that again. Let's make this more clear. Alright, so 9x squared times x plus 3. So looking at the denominator here, we can see the excluded values. X cannot be equal to 0, as that would make the denominator undefined. Or x can also not be equal to negative 3, because negative 3 would make this denominator undefined. Okay, so this will be the final answer here. Alright, I got 2 more examples for you, and it's only because there's a reasonable variety of examples. And I'm also doing only subtraction problems, because if you can do the subtraction problems, additions work automatically. Alright, so let's move on to another one. Here we don't have a common denominator. It's actually, we can multiply them by each other, so I'm going to recommend that for now. So this will become 7x times 20x plus 16 by multiplying the denominator here by that as well. 20x plus 16 minus, this needs a 2x, so this will become x minus 2. I don't know where this little line came from. X minus 2. We have to add in a 2x here. Oh, and a 2x down here. Now we have a common denominator. Alright, so if we combine the terms, or just, is it really necessary? Yeah, let's put them all together. So that's 140x plus 70 and 42 would be 112. All of that is over 40x plus x squared plus 32x minus 2x, excuse me, 2x minus 4. Oh, 2x squared minus 4x. All of that is over this same denominator, because they're the same. That's 40x squared plus 32x. Alright, so now we can write this minus this over a common denominator. So that is 140 x plus 112 minus, uh-oh, I seem to be having a trouble here with the computer, minus 2x squared minus 4x. All of this is over 40x squared plus 32x. Alright, so I'm going to scroll down a little for more room, and we'll continue the problem right here. Alright, so 140x minus negative 4x would be 144x. We have a 112. This doesn't have any like terms, so that's still 112. And this negative 2x squared has no other common terms. All of this is over 40x squared plus 32x. Excuse me. Alright. Alright, so now we should factor and see if we can simplify this expression. Alright, the numerator has a GCF of negative 2, So it's negative 2 x squared. Oh, I left out a plus, I think. Plus, what is it, 72? 72 plus 55 and 1, 56. Alright, and our denominator has a GCF of, what goes into both of these? 8x. Leaving a common denominator of, leaving a GCF of 5x plus 4. Now we can kind of stop here because we can see that this trinomial, while it should be factorable, will not have a term that starts with 5, so its factors won't cancel out with the 5x. But these can simplify a little. The 2 goes into itself. Here, let's use red for the cancellations. 2 goes into itself. 2 goes into itself once, and 2 goes into the 8 4 times. So putting these things back together, our final result is negative x squared plus 72x plus 56 all over 20x squared plus 16x. So what are the excluded values? Well, they're again easiest to identify in factored form. So this expression is undefined when x is equal to 0 because of this term here. And it's also undefined when this is equal to negative 4/5. Okay, so x is not equal to 0 or negative 4/5. If you plug in 0 here, this denominator will be equal to 0. If you plug in negative 4/5, this will make the denominator equal to 0. We have one last example to look at. This one was surprisingly long. Alright, let's take a look at it. Okay, this one seems much easier. They both have two different binomial denominators, so we have to make them have the same ones. So let's use yellow. Multiply this by x minus 2, and this by x minus 2. Multiply this by x minus 7. Is that plus 7? Plus 7. And x plus 7. Now they have a common denominator. The denominator is the product of these two binomials. So this will become 4 x minus 2 over... I'm actually not going to multiply these together because I might just wind up having to pull them apart again. So it's this expression minus this one, 7, actually we could put this partially together. So the numerator here would become 4x minus 8, and that's going to be taken away from 7x plus 49, all over this common denominator of x minus 2 and x plus 7. I'm actually going to leave these in factored form because it'll be easier to do cancellations. So let's do subtractions. 4 minus 7 is negative 3, and negative 8 minus negative 49 is negative 57. All of this is over x minus 2 and x plus 7. Alright. Okay, so now factoring the numerator here, I think a negative 3 goes into both of these terms. That's x, and this will become positive, I want to say 17? 17? No, 19? 19. So this isn't going to cancel with the denominator, so we could just stop here. And we could see the excluded values are x is not equal